Good morning, everyone. Welcome to Monday, April 6th. We are going to spend today going over all the different types of factoring that we learned over the past 2 weeks. You will have worksheet practice, and we will go over that worksheet practice in just a moment. And this worksheet practice will be due by Sunday at midnight. And that will lead you into spring break, and that will be it until we come back on, I believe it's April 20th. In the worksheet practice, there are 4 parts. Each part has 4 questions, but 2 of the questions, in fact, the first 2 questions are example problems that I'll be going over on the whiteboard, and then the follow-up questions will be for you to complete. If you have access to a printer, then I would suggest printing this out. And if you don't have access, then I'll show you what you can do afterwards. Let's take a look at what this looks like. So your worksheet starts off with directions, factor each expression using the given method. This is the instructional video that goes over the examples if needed. And then I'm asking you to multiply to check. So instead of giving you the answers this time, I'm actually going to assess your ability to factor and multiply to check. So on the left-hand side, you will be factoring the expression. These are the examples that we will be going over in this video, and then you'll multiply to check over here. If these 2 match up, that's how you know that you did it correctly. Then you will be asked to do 2 examples. These are what you will be graded on, is your ability to actually show your work in factoring and multiply to check. So part 1 is GCF factoring, factoring out the greatest common factor. Part 2 is P's and Q's factoring. So these are all trinomials with a leading coefficient of 1. So there's no number out in front, which leads me to understand I can use P's and Q's factoring here. I don't need to use flip and slide, supergrouping, double cross, any of those. So these are the ones that we will go over together. These are the 2 that you will do for your assignment. Part 3, factor by grouping. These are all 4 terms polynomials. We will go over examples 1 and 2 in the video. You will do 1 and 2 in your assignment. And then part 3 is factor by supergrouping, double cross, or slip and slide. You get to choose the method that you prefer. So if you like supergrouping, then you don't have to do double cross and slip and slide. Or if you like slip and slide, you don't have to do double cross supergrouping. You get the idea. You pick the method that works for you. I will go over all 3 methods for both of these examples so that you can see them. And then you will do these 2 for your assignment. And that is the end of the worksheet practice. So it is 4 pages, but it's really only 8 questions that you are expected to do, because the first 2 questions on each page is something that we're going to go over right now. Now, if you do not have access to a printer, here's all that you have to do. You're going to grab a piece of paper. It can be binder paper, printer paper, yellow pad paper, whatever. Grab a piece of paper and you're going to fold it in half. Okay. After you fold it in half, put a nice even crease down the middle. Okay. You're going to have 2 columns, a column on the left and a column on the right. On the left-hand side, you're going to write factor. And on the right-hand side, you're going to write multiply to check. So basically, this mimics what you see in the worksheet practice. Factor on the left, multiply to check on the right. Label it with the number. So if I were to do part 1, this would be part 1, number 1, write the question, show the work, multiply to check. Number 2, write the question, show the work, multiply to check. Then you take a picture of this and you submit it to me. Now, if I cannot read your writing, I will not grade it. I will ask you to resubmit it. So for those of you who struggle with penmanship, now is your chance to take your time, make sure that you're actually going through this. Okay, so I'm going to set up the whiteboard behind me here. And we're going to go ahead and get started with part 1, factoring out the GCF. So again, these are examples that you can either copy onto your worksheet for later on, or you can just follow along, pause the video, do number 1 and 2 in part 1, etc. So example number 1 is factoring out GCF. Looks like negative 80 k squared. Oops, that's negative 8. Negative 80 k squared plus 72K. All right, for this part, we are doing GCF factoring, which means you find the greatest common factor of both terms, write them both as products, and then factor out that common term. Now, something stands out to me here. The leading coefficient is negative. If you remember from last week, when the leading coefficient is negative, that means our greatest common factor also has to be negative. So I start by looking at the two coefficients. I have negative 80 and I have positive 72. And I ask myself, what goes into negative 80 and positive 72? And the first number that comes to mind is 8. 8 goes into 80 10 times, and 8 goes into 72 9 times. So I'm going to start by factoring out a negative 8 because it is a negative leading coefficient. Now, when I write both of these as products using negative 8 times positive 10 is how I get negative 80. K squared is just K times K. So all I've done is I've just written the first term as a product using negative 8. Now I'm going to write the second term as a product using negative 8. Now careful, this is a positive 72. So positive 72 is negative 8 times negative 9, and then times the K. So negative times a negative is how you get a positive. So that's the steps that some of you can do in your head, which is great. If you can't do it in your head, you can always write it out. What do they have in common? Well, we know they're going to have negative 8 in common. But what else do you see that they have in common? They have one of these K's in common as well. So that tells me that the greatest common factor here is negative 8K. Whatever they have in common always goes out in front. And then what are you left with when you take out the negative 8K? Well, when I take out the negative 8K from the first term, I'm left with 10K. Let's double check that real quick. Negative 8 times 10 is negative 80. K times K is K squared. When I take out the negative 8K from the second term, what do you see? I see a negative 9, which means this becomes minus 9 because a negative times a negative is how you end up with a positive. Now, there is no answer key. So in order to check your work this time around, you have to actually multiply. So over here, I'm going to take my answer, negative 8K times 10K minus 9. And in this case, the way that we multiply to check is we check using just regular old distributive property, because this isn't a product of two binomials. It's a product of a monomial or a single term by a binomial. That just means all we have to do is regular old distribute. Take the outside term, multiply it by both inside terms. So here we go. Negative 8K times 10K. I'm going to write that out. Negative 8K times 10K. And then you have negative 8K times negative 9. So I just wrote it out so that we could kind of look at it. Now, the order doesn't matter when you're multiplying. So in this case, I could do negative 8 times 10 first and then K times K. So negative 8 times 10 is negative 80. K times K is K squared. Same thing over here. Negative 8 times negative 9 is a positive 72. And notice that that becomes addition because negative times a negative is positive. Bring along the K. Now, here's how you can tell if you did this correctly. Are these two exactly the same? Yes. Once you have determined that they're exactly the same, that shows that these are equivalent, and this is your correct answer. So that's how you do example 1. Let's take a look at example 2. Example 2, the binomial is 12p squared minus 9. So we do the same thing. We find the greatest common factor of 12 and 9. So I'm thinking 3. 3 goes into 12 4 times, 3 goes into 9 3 times. So I'm going to write them both using 3 as a common factor. So 12 is 3 times 4. P squared is P times P. And this minus 9 is basically minus 3 times 3. All I did was bring the subtraction down to keep the structure the same. What do they have in common? Well, I see a 3 and a 3. So that tells me that the greatest common factor here is 3. Notice that this expression has p times p, but there are no p's over here because the second term is not a variable expression, it's a constant. So I can't take a variable if there isn't one. So in that case, my GCF is just 3. Take that out, put that in front. What do we have left? Well, when I take 3 out of the first expression, I'm left with 4 times p, which is 4p squared. When I take 3 out of the second expression, I'm left with minus 3. Now we're going to multiply to check. So bring that expression over here. 3 times 4p squared minus 3. Again, because this is a product of a monomial and a binomial, to check, you just do simple distributive property. I'm going to write it out just so that you can see my work, but you don't have to write it out when you do your check. If you are able to do that step mentally, that's totally fine. 3 times 4p squared minus 3 times 3. Let's see. 3 times 4 is 12. Times p squared is just 12p squared. And 3 times 3 is 9. Are these the same? Yes, they are. That's how I know I did this step correctly. And that's how I know this is my correct answer. My advice for you now is to pause the video, do part 1, numbers 1 and 2, comparing it to these 2 examples, and then we'll move on to part 2. Okay. Part 2, this time we're factoring using P's and Q's. Here's how I can tell. I can tell we're going to use P's and Q's because it is a trinomial, which means 3 terms, and the leading coefficient is 1. So anytime it is a trinomial, leading coefficient 1, we get to use P's and Q's, which basically means we're going to factor this in one step. So I'm going to set up what my answer is going to look like first. So I know my answer is going to be a product of 2 binomials. I also know that the first term in my answer is going to be b, because b times b is how I get b squared. I'm setting that up first because I know what my answer is going to look like because I know how P's and Q's work. Now we play the game to find these other 2 numbers, which we know these 2 numbers have to multiply to negative 15 because the first 2 multiply to the first term, the second 2 multiply to the last term. We'll see that when we multiply to check. But it can't just be what 2 numbers multiply to 15. It's also what 2 numbers add to 2. So we play the game. What 2 numbers have a product of negative 15 and a sum of positive 2. So we'll play that game down here. What times what is negative 15? That when I add them together, I get positive 2. Now we think. Products of negative 15. Well, 5 and 3 are the only ones that come to mind. Let's try negative 5 and positive 3 and see what happens. Negative 5 times positive 3 is negative 15. Negative 5 plus 3 is negative 2. So I'm close. When you're close, chances are that just means that you need to flip the negative and the positive. So instead of negative 5 and positive 3, let's try positive 5 and negative 3. 5 times negative 3 is still negative 15. 5 plus negative 3 is 2. What do we do with this information? These are the second terms in your binomials. So I have a positive 5 and a negative 3. Now you know by this point that this is actually not the only correct answer. You could also write it as b minus 3 times b plus 5. The order of the 2 binomials doesn't actually matter. Well, how do we know that we're correct? We're going to multiply to check. Now, here's the deal. We can't just use regular old distributive property anymore because instead of a monomial times a binomial, we have a binomial times a binomial. So there's 2 ways to do this. You can either check with double distribute, which means I do b times b minus 3 plus 5 times b minus 3, or we can use area model. I like the area model, as you know, so I'm going to start with that. Draw a window. Across the top, put your first binomial, b plus 5. Down the side, put your second binomial, b minus 3. Now all we're doing is we're multiplying everything in the boxes, and we're going to see if it ends up with what we started with. B times B is B squared. Positive 5 times B is positive 5B. Negative 3 times B is negative 3B. And negative 3 times positive 5 is negative 15. So already what stands out to me is I see B squared and a negative 15, but I don't see a 2B. If you remember, that 2B comes from combining our like terms inside of the window. So when we take out all of our terms from the area model, we're going to start with the term with the greatest degree, B squared. What is a positive 5B minus a 3B? That's a positive 2B. And then our last term is negative 15. Is this exactly what we started with? Yes, it is. That's how we know that we are correct. Now, I want to show you something really quick. By exactly, I mean this. What if I had changed this to a negative 5 and a positive 3? Honest mistake happens a lot. What would change? Well, what would change is that this would be a negative 5 and this would be a positive 3, because positive 3 times B and negative 5 times B, which then when I combine them would give me a negative 2B. Is that exactly the same? No, it's not, because my original expression had a plus sign, my ending expression has a minus sign. Those are not the same expression. So that's why you have to be very careful when you are checking that it is exactly what you ended with. So if this were to happen, I know I'm really close, which means I probably made an error in my P's and Q's game. In fact, I'm so close, all I have to do is change my positives back to negatives, my negatives back to positives, and voila, I'm back to adding 2B. On to example 2. Same idea, 3 terms, trinomial, leading coefficient is 1. That's how I know I can use P's and Q's. So step 1, I'm going to set up my answer. I know my answer here is a product of 2 binomials. And I know the first term in both binomials is n, because n times n is how I get n squared. So I know that is kind of like what my answer looks like. Now we have to find the 2 numbers that have a product of positive 20 and a sum of positive 12. In other words, we're going to play the P's and Q's game. All right, product of 20, sum of 12. Let's see, how about 4 and 5? 4 times 5 is 20, 4 plus 5 is 9. 9 is not 12, which means 4 and 5 didn't work. What else goes into 20? How about 20 and 1? 20 times 1 is 20. 20 plus 1 does not equal 12. Always check 1, by the way. Chances are if you can't figure out what the product is, it probably involves 1. Doesn't work here though. What's the only other product pair for 20? How about 2 and 10? 2 times 10 is 20, 2 plus 10 is 12. We look good. So our final 2 terms are positive 2 and positive 10. At least we think they are. We don't know for sure until we multiply to check. So over here, we have n plus 2 times n plus 10. And we want to see if after I multiply this, do I end up with the exact same expression that I started with? So here we go. I'm going to open up my window. First binomial goes across the top. Second binomial goes on the side. So now I have n plus 2 across the top, n plus 10 down the side. Multiply in each individual box and see if they all add up to n squared plus 12n plus 20. So here we go. N times n is n squared. That's a good first sign. Positive 2 times n is a positive 2n. Positive 10 times n is a positive 10n, and positive 2 times positive 10 is positive 20. So again, you see the n squared and you see the positive 20, but I don't see a 12n right off the bat until I combine my like terms. A 10n and a 2n can be combined. So let's take it out of the box. First term is n squared because that is the greatest degree. Combine the next two. 2n plus 10n is 12n. And our last term is plus 20. Is it exactly what we started with? Yes, it is, which is how we know that we factored correctly. Go ahead, pause the video at this time and finish up part 2 of your worksheet practice with your other 2 questions, and then restart the video to go over the examples for factor by grouping. Okay, part 3, factor by grouping. So in all of these expressions, you're going to be seeing 4 terms, none of which that can be combined. So like I can't combine a 12n squared plus a 7n in the first example. So all I can do here is factor by grouping. So here's example number 1, 6n cubed plus 12n squared plus 7n plus 14. Step 1, it is called factor by grouping for a reason. We're going to group them into 2 binomials. Since it's addition here, I know I don't have to do any moving around negatives or anything, so I'm just going to put my groups in. So step 1, group. Group the first 2 terms together, group the last 2 terms together. Step 1 is done. Step 2, how do you factor a binomial? Well, if you rewind to earlier in this video, we were factoring binomials in examples 1 and 2 in part 1. You do it with GCF factoring. So you look at the first binomial and you go, what's the greatest common factor of 6n cubed and 12n squared? Well, I know 6 goes into 6 and 12, so I'm going to start with that. 6 is 6 times 1, and then n times n times n. That's our first term. Over here, I kind of didn't give myself enough space. I'm going to give myself a little more space here. So here's your first term, 6 times 1 times n times n times n. Second term, 12 is 6 times 2, and n squared is n times n. So what do they have in common? I see a 6, and I see an n in common. So that means the greatest common factor of the first binomial is 6n. Now, after we factor out 6n, what does that leave us with? That leaves us with, if I take out 6n here, 1 times n is just n squared. Wait a minute, I made a mistake. Hopefully you found that. They don't just have 6n in common. I forgot about this n over here. They actually have 6n squared in common, don't they? I didn't realize that the second term had n times n and this had n times n. So let me back up a little bit. I'm factoring out 6n squared. That was an honest mistake. I didn't even plan that. So when I take out 6 times n, I'm left with 1 times n, or just n remaining. So let me try that step again. So again, I realized they have 6 times n in common, which is 6n squared. That was my mistake. In the second term, when I take out the 6 times n, I'm left with a positive 2. Yeah, I'm glad I caught that mistake because that would have been embarrassing. All right, second binomial, what do 7n and 14 have in common? They have 7 in common. So 7n is just 7 times 1 times n. 14 is 7 times 2. Notice that in this case, only the first term has the variable n. So the greatest common factor here is just going to be 7. It is a positive 7, so we're going to put that out in front. And we're left with 1 times n, which is just n, and positive 2. Now, at this point, I can already tell that what I did is pretty much on the right track. And here's how I can tell. You need to have a common, excuse me, you need to have a common binomial factor. If you don't have the same binomial here, that means you made a mistake in your GCF factoring. For example, if I hadn't factored out n squared, this would not match this one. And that's how I would know that I made a mistake. If you do have a common binomial factor, you're going to factor that part out first, n plus 2. And then your second binomial is the GCFs of the first and the second. So 6n squared plus 7. And there we have it, or at least we think we do. You never know until you check. So coming over here, I have n plus 2 times 6n squared plus 7. Again, I'm going to check using the area model because it is a product of two binomials. Across the top, n plus 2. Down the side, 6n squared plus 7. And then I just multiply each individual term, put the product of those in each box. So 6n squared times n. Well, this is 6 times n times n. So really, this is 6 times n times n times n. That's n to the third power. So this is just 6n to the third power. All right. 6n squared times 2. Well, I'm just doing 2 times 6, which is 12, times n squared is a positive 12n squared. N times 7, or 7 times n, is just a positive 7n. And positive 7 times positive 2 is positive 14. Now, the interesting thing about this, as opposed to what we were doing with factor by grouping, is there are no like terms here. This is an n cubed, an n squared, an n, and then a nothing, just a constant. That means there are no like terms. You're just going to pull out each individual term and put it in standard form, which, if you remember, means greatest degree to least degree. So the greatest degree here is 6n cubed. So my first term is 6n cubed. That matches what I started with. The next greatest degree is positive 12n squared, which also matches. The next greatest degree is a positive 7n, which matches. And the last one is a positive 14, which again also matches. Is this exactly what you started with? Yes. By the way, if you ever end up doing double distribute and you end up with something in a different order, always put your expression in standard form. In other words, reorder the terms from greatest to least and then see if it exactly matches. Right? Like, you might end up with terms kind of out of order, but if you put it into standard form and it matches, that's how you know you were correct, which leads us to believe this is the correct factored form of that 4-term polynomial. All right, last example in part 3, factor by grouping. In this example, we have 56n cubed minus 8n squared plus 7n minus 1. Step 1 in factor by grouping is in its name, grouping. Now here, I can tell that this one also isn't going to give me that much of a trouble because it is also addition. But remember, if it is subtraction, which I do believe one of your worksheet problems, yes, number 1 contains subtraction, that subtraction symbol does have to go along with the first term. So step 1, I'm going to do some grouping. Put in my groups, bada bing, bada boom. Step 2, GCF, because that's the only way that we can factor a binomial. If it has 2 terms, right now, all we know is find a GCF. Excuse me. So here we go. 56n cubed and a minus 8n squared. I'm going to say 8 goes into both of them. Because this is a positive, I'm just going to factor out positive 8. So here we go. 56n cubed is 8 times 7. That's how we get 56. And then n cubed is just n times n times n. Minus 8n squared is just minus 8 times 1. That's how you get an 8 times n times n. So those are basically the products of the first 2 terms. What do they have in common? Well, they have an 8 in common. We knew that because that's what we were factoring out. And I'm not going to make the same mistake twice. They have an n times n in common, which means n squared. So my GCF here is 8n squared. When I factor out 8n squared, what am I left with? Well, let's see. Take out the 8 and the n times n in the first term, and I'm left with 7n. Take out the 8 and the n squared in the second term, and I'm left with just a minus 1. Notice how the entire term was factored out, which means you're always going to be left with a factor of 1 because 1 goes into everything. Do the same thing in the second binomial. What goes into 7n and 1? You might be thinking nothing, but be careful. There's a number that goes into everything. In fact, I just showed it to you with my hand. 1. 1 goes into everything. So when in doubt, you can always factor out 1. Sometimes it doesn't make a difference, but in factor by grouping, you need to factor out something. So always factor out 1. So 7n is just 1 times 7 times n. And the minus 1 is just minus 1 times 1. Essentially, when you factor out, whoops, wrong color. When you factor out 1, you are left with, there goes my eraser, you're left with the same exact expression. Factoring out 1 doesn't change anything. So when I factor out a 1, I'm still left with 7n minus 1. All right, let's see. Do I have a common binomial factor? Are these the same? Yes. Do I have 2 GCFs to make up my second binomial? Yes. Now we can do the final step. Whatever they have in common can go out in front. 7n minus 1. And then the second binomial is the combination of your 2 GCFs, 8n squared and a positive 1. There's your 2 binomials. Let's multiply to check. So over here, I have 7n minus 1 and 8n squared plus 1. Let's set up my window. First binomial goes across the top, 7n minus 1. Second binomial goes along the side, 8n squared plus 1. Let's multiply them out and see if we end up with what we started with. 8n squared times 7n. So order doesn't matter. So in this case, I can do 8 times 7 first. 8 times 7 is 56. And then n squared times n is just n times n, which means n to the third power, 56n cubed. Negative 1 times 8n squared is just negative 8n squared. Because negative 1 times 8 is negative 8, and then the n squared just comes along. Positive 1 times 7n is just 7n, and positive 1 times negative 1 is negative 1. Again, you'll notice that there's no common, or there's no like terms. I can't combine any of these terms here because we have an n squared, an n cubed, an n squared, an n, and a constant. So I just pull them out in order from greatest degree to least degree, or in standard form. So 56n squared has the greatest degree, so that'll be my, 56n cubed has the greatest degree, that'll be my first term. A negative 8n squared is my second term. Positive 7n is my third term, and minus 1 is my last term. Is it an exact replica of what we started with? 56n cubed minus 8n squared plus 7n minus 1. Yes, it is. That's how we know we did our factoring correctly. Pause the video now and go ahead and try the number 1 and 2 from part 3, factor by grouping. Okay, part 4 and our final practice in the worksheet. For these, you'll notice that they are all trinomials with a leading coefficient other than 1. So like 3v squared, or in the second example, 5r squared. The leading coefficient is an actual number other than 1, which leads us to believe that we cannot use regular old P's and Q's factoring. So to do these, I'm going to do the first example using supergrouping. I'm going to multiply to check to make sure my answers correctly, and then I'm going to go back and do the example using double cross and slip and slide. So I'm going to do all 3 methods, but you do not have to do all 3 methods. You only do the method that makes sense to you. So feel free to like fast forward the video to when I do the method of your choice and watch and copy down in that sense. Super grouping was the one that you voted for the most in the Google survey last week, so that's why that's one I'm going to do first. So without further ado, super grouping. So super grouping starts off with the P's and Q's game with a twist. We're going to find 2 numbers that have a sum of 29, because if you remember, our goal is to split the middle term to create a 4-termed polynomial. That's the only way that we can do grouping, is if we have 4 terms. But to find the product, you're going to do what 2 numbers have a product of the first coefficient times the last term. So 3 times negative 10 is negative 30. So when I play this P's and Q's game with a twist, I'm asking myself what two numbers have a sum of 29, but a product of negative 30, not a product of negative 10. It won't work if you try to do what two numbers have a product of negative 10. So now I play the game over here. What times what is, I'm going to make a little bit of room. What times what is negative 30? That when I add them together, I get positive 29. This one seems like a bit of a tough one. So let's start doing some guess and check. Negative 30. How about negative 6 and 5? Do I believe that? Negative 6 and 5? Yeah, try negative 6 and 5. Negative 6 times 5 is 30. Negative 6 plus 5 is negative 1, which is nowhere near positive 29. So that's not right. What about 3 and 10? Negative 3 times 10 is negative 30. Negative 3 plus 10 is 7. Also nowhere near. 2 and 15. Negative 2 times 15 is negative 30. Negative 2 times 15 is 13. Also nowhere near. What number am I forgetting about? 1. 1 goes in everything. Always check 1. When in doubt, check 1. Let's see. Negative 1 times 30. Negative 1 plus 30. Let's see. Negative 1 times 30 is negative 30. Negative 1 plus 30 is positive 29. We found our P's and Q's. Remember, it is with a twist. And the twist here is that you can't just put it right into the factored form. What do we use this for? We use these two terms to split the middle term, because eventually we're going to have to do grouping. So here we go. My first term is the same, 3b squared. My second term just became negative 1v. My third term just became positive 30v. And my last term is negative 10. Notice that this is the exact same expression here. These are equivalent because negative 1b plus 30v, if I were to combine these, it would give me a positive 29v. So these are equivalent expressions. All I did was change it into 4 terms so that I could do grouping. Now that it's in 4 terms, let's go through our grouping, which we just did in part 3. So it should be fresh on our mind. Step 1, grouping. Luckily it's addition, so I know I can just put my groups in. Step 2, GCF. What's the greatest common factor of 3v squared and negative 1v? I think the only thing that they have in common is a v. So 3v squared is 3 times v times v. Negative 1 is negative 1 times v. All they have in common is a v. So I pull out the v. I'm left with, looks like 3v in the first term and minus 1 in the second. Now I know how factor by grouping works. My goal is to get 3v minus 1 again, okay? It's kind of hard for you to see that v. There it is. So let's see, what's the greatest common factor of 30v and 10? I know 10 goes into both. 30v is 10 times 3 times v, and 10 is just 10 times 1. Keep that a minus sign. Let's factor out the 10, because that's what they have in common. And it is a positive 10 that we're factoring out, because this is a positive 30v. And what are we left with? Well, when we take out 10 from the first term, we're left with 3v. And when we take out 10 from the second term, we're left with minus 1. Looking good, because we have a common binomial factor. So our final answer here is we take the common binomial factor, 3v minus 1, and we multiply it by the GCF from the first two, v plus 10. All right, one way to see if it's correct. So I'm going to check it, and then I'm going to go back and do it using double cross and flip and slide. So let's check it. 3v minus 1 times v plus 10. Does it give us what we started with? Let's open up our window. Across the top, 3v minus 1. Down the side, v plus 10. Let's see if it works out. 3v times v is just 3 times v, which is 3v squared. Negative 1 times v is just a minus 1v. Positive 10 times 3v is a positive 30v. And positive 10 times negative 1 is negative 10. This is different from normal grouping because I see like terms, which means when I pull all of my terms out of the window, I'm going to have some combining to do. I can combine the 30v's with the negative 1v, and that'll help me with my final answer. So here we go. First term is the term with the greatest degree, which is 3v squared. Negative 1v plus 30v, or just 30v minus 1v, is plus 29v. And then a minus 10. Is that exactly what we started with? Let's see. 3v squared plus 29v minus 10 is exactly what we started with, which means this answer is correct. Now we're going to do the exact same example using double cross. So I'm going to keep the check up over here, and I'm just going to erase supergrouping and replace it with double cross. If you only like supergrouping, feel free to pause the video now and try example 2 on your own. Then just fast forward in the video until we get to supergrouping again with example 2 and compare your work. Okay, same example, this time done with double cross. So for double cross, you have to start out by creating your structure. So I'm going to start with a horizontal line under the first term, x going down, and a horizontal line under the last term. Same thing, horizontal line under the first term, x going up, horizontal line under the second term. This is a guessing game. We're trying to find the numbers that multiply to the first term, multiply to the last term, but when we multiply them all out, we end up with a positive 29b. The middle term is always the sum. You will find that is the case with all of these methods. So here we go. What times what is 3v squared? Well, I know v times v is v squared. And what times what is 3? That's just 3 times 1. That's the only way to get 3v squared. So 3v times 1v is 3v squared. Now we have to play a guessing game. What times what equals negative 10, but also when I multiply, I get a positive 29v. So this is the guessing game part. So let's try negative 5 and positive 2 and see what happens. I don't think that's right, but we'll see. 3v times a positive, oh, this is a positive 2. 3v times a positive 2 is a positive 6v. 1v times a negative 5 is negative 5v. When I add a negative 5v to a 6v, I do not get 29v. So this was wrong. Let's try, before we completely disregard negative 5 and positive 2, let's just try flipping them. Put negative 5 down here, oops, not v, and positive 2 up there. You never know, maybe by flipping them, it will work out. Let's see. 3v times negative 5v is negative 15v. 1v times 2v is positive 2v. 2v minus 15v is not positive 29v. So 5 and 2 are officially out. I don't think that those two are going to work. Let's try 10 and 1. What if we did a negative 1 and a positive 10? Let's see what happens. 3v, and this is a positive 10. 3v times positive 10 is positive 30v. And 1v times negative 1 is a negative 1v. Does negative 1v plus 30v equal 29v? Yes, it does. Oh, that worked out so nicely. So that means we found our two numbers. So I'm just going to take their signs. This is a positive 10 and a negative 1. And then you just pull your two binomials out. My first binomial is 3v minus 1. And my second binomial is 1v, which is just v, plus 10. Let's see, does that match our answer from supergrouping? Yes, it does. So even using double cross, I ended up with the same answer. Now we're going to do it. So if you like double cross, pause the video now. do the second example, come back when we do it again. Now we're going to do flip and slide. All right, example number 1, done for the final time using flip and slide. So flip and slide, there are 2 parts to this. Flip, the first coefficient, the leading coefficient down to the end, do your P's and Q's, and then slide it back underneath at the end. Remember, this is like normal P's and Q's, but you're going to be working with quotations if you remember. So here we go. Step 1, flip the leading coefficient down to the end, which basically means you're multiplying 3 times -10. And now we're working in like this alternate universe of a different polynomial. So this is like a parallel universe with a different trinomial. I've been watching a lot of Marvel movies, so that's why I'm bringing up different universes. Here we go. V squared plus 29v and minus 30. That's this alternate universe in the quantum realm. It's because 3 times -10 became -30. Once I split that 3 down, I'm working with a different trinomial. Nice part about working with this trinomial is I get to use the regular P's and Q's like we did in part 2. What 2 numbers have a product of -30 and a sum of 29. I feel like we've already done that. In fact, we did already do this when we were doing supergrouping. If you remember from supergrouping, we already did all of this work. Those 2 numbers were, if I remember correctly, -1 and positive 30. So in our alternate universe, we're just going to factor using regular old P's and Q's. This becomes V minus 1 and V plus 30. Because V times V is V squared, -1 times 30 is -30, and -1 plus 30 is 29. Now time to bring it back into the regular universe. The first step was flip, the last step is slide. I take that leading coefficient and I slide it underneath those terms. And then if I can simplify, I do, and if I can't simplify, I just slide it even further. So can I simplify 1 divided by 2? Not evenly, so I just slide that 2 in front, which is basically multiplying both of these by 2. This becomes, oh my gosh, I split a 2. Why did I slide a 2? Miss Angel. I got too obsessed with my quantum realm thing. You don't slide a 2, it's a 3, not a 2. Sorry, so I slipped 3, now I slide 3. See, I'm still even making mistakes. Okay, still can't divide 1 by 3, so I slide the 3 in front. 3v minus 1. And then I can simplify 30 divided by 3, that's 10. So this becomes v plus 10. Is that what I ended up with in the other 2? 3v minus 1 times v plus 10? Yes, it is. So it doesn't matter the method you use. You will end up with the correct answer either way as long as you're doing the work correct. So if you are a slip and slide fan, go ahead, pause the video now and try example 2. All right, example 2. Now, for those of you who had paused the videos before, you're basically just comparing. And if you are doing this for the first time, then here we go, super grouping. So super grouping is kind of like P's and Q's with a twist. We're going to start by finding 2 numbers that have a sum of 44. That's always the same. But to find the product, we take the first term and the last term and we multiply them. 5 times -9 is -45. So now we play the P's and Q's game with a twist. What 2 numbers have a sum of 44 and a product of -45? So let's play the game. I'm going to make some space here. So what times what is -45? That when I add them together, I get +44. -9 and 5, that's not going to add up to 44. In fact, if you notice, 44 is only 1 away from 45, which leads me to believe that 1 is going to be a factor. That's just a little bit of trick there for you. Now the question is 1 negative or positive? Well, let's try +1 and -45 and see what we end up with. +1 plus -45 is -44, so I'm close. just take that negative and put it over with the 1. So -1 and +45, that works. -1 times +45 is -45. -1 plus 45 is 44. Now we take our middle term and we're going to split it using those two numbers. So our first term is still the same, 5r squared. Now we're going to use our -1r, our positive 45r, and our -9. So all we've done is we've used our P's and Q's to break up the middle term. Now we can do our grouping. Here we go. It's addition, so I can just put my parentheses in, my groups in. Find the GCF of the first two terms and the second two terms. So 5r squared and 1r. 5 and 1 don't have any factors in common other than 1. So that means, I think just r is in common. So this is 5 times r, and this is -1 times r. So they only have r in common, so I factor out r. When I factor out r, what does that leave me with? Well, let's see. Take out the r, and I'm left with 5r minus 1. Let's look in the second term. I know my goal is to get 5r minus 1 here. I'm thinking ahead. 45r and 9. Let's see. 45 is 9 times 5, and then bring along the r. 9 is just 9 times 1. So what do they have in common? They have 9. So when I factor out this positive 9, what does that leave me with? If I take out the 9 here and the 9 here, that leaves me with a 5r in the first term and a -1 in the second term. Do these match? Yes, they do, which means I can continue. Those two don't match. I can't go. I can't do anything. So my first binomial here is going to be 5r minus 1. Second binomial, r plus 9. But there's only one way to be sure. We're going to multiply to check. So I'm going to come on over here. Woo! And let's multiply to check. So our answer here was 5r minus 1 and r plus 9. I'm going to use the model, the area model, the window again. I just like the window. Across the top, 5r minus 1. Down the side, r plus 9. Let's see if it's correct. 5r times r is 5r squared. -1 times r is -1r. 5r times positive 9 is positive 45r. And positive 9 times -1 is -9. I see some like terms. -1r and positive 45r can be combined. So this becomes 5r squared plus, let's see, 45r minus 1r is 44r minus 9. Is that exactly what we started with? Yes, it is. So if you like supergrouping, feel free to pretty much stop the video now and go ahead and go over supergrouping in the last two problems on this worksheet. And then you can fast forward to the end so that we'll talk a little bit about all of this together. Up next is same expression with double cross. All right, double cross, here we go. I went ahead and set up the double cross structure already. So again, horizontal lines underneath the first term, horizontal lines underneath the second term. And then as always, excuse me, our sum is the middle term. The middle term is always the sum. That's what you'll find when it comes to factoring. So we're trying to find what two numbers multiply to 5r, what two numbers multiply to -9, and then when we have our multiplication double across, they add up to 44r. Here we go. R times r is r squared, so we know both of these are going to have an r, and one of them is going to be 5 and one of them is going to be 1, because 5 and 1 are the only ways to get 5r squared. What two numbers multiply to -9? The first two that come to mind are -3 and +3. So I'm going to put -3 here and +3 here, and let's see positive 4. I'm not even close. Positive 3 here and see if it works. Let's see. 5r times 3 is 15r, positive 15r. 1r times negative 3 is negative 3r. Are those two going to add up to 44r? Not a chance. Well, let's not take out the 3's just yet. What if I move the negative down here and the positive up there? Would that do it? Well, 5r times negative 3 makes that a negative 15r, and 1r times positive 3 makes that a positive 3r, still nowhere close to 44. So 3 and negative 3 are out. What else goes into 9? How about the number that goes into everything? 1. Let's try it. Let's try a positive 1 and a negative 9. Here we go. 5r times negative 9 is negative 45r. 1r times positive 1 is positive 1r. Do these add up to 44r? No, they add up to negative 44r because negative 45r plus 1r is negative 44r, which means I'm close. Whenever you're close, just try flipping it around. Let's make it a negative 1 and a positive 9. That would make this positive 45r and negative 1. Does negative 1r plus 45r equal negative or 44r? Yes, it does. So this was a negative 1 and a positive 9, which means we found our two numbers. All we have to do is pull the two binomials. The first binomial here is 5r minus 1. And the second binomial, 1 times r, is just r plus 9. Is that what we got with supergrouping? Yes, it is. So example 2 done with double cross. Feel free to pause the video now or stop the video now if you like double cross, and do the remaining 2 examples or the remaining 2 problems on your assignment. If not, stay tuned. We are going to do slip and slide. Here we go. Slip and slide, example 2. 2 steps, slip, slide, with some P's and Q's in there. Okay, step 1, slip the 5 down to the end. That's 5 times negative 9, which we know is negative 45. Now we're traveling into an alternate universe where we're dealing with a different trinomial altogether. Our new trinomial is r squared plus 44r minus 45. Alternate universe, different realm trinomial. With this alternate universe trinomial, we're going to play the P's and Q's game. What two numbers have a sum of the middle term, because the middle term is always the sum, and a product of the last term. So what times what is negative 45? That when we add them together gives us positive 44. I feel like we already did this because we did it with supergrouping. We know that 45 is only 1 away from 44, which leads us to believe that 1 is part of it. Let's see. I believe if I remember correctly, it was negative 1, and positive 45. Let's see if that was right. And again, I'm just pulling that from when we did supergrouping. Negative 1 times 45 is negative 45. Negative 1 plus 45 is 44. Cha-ching. So now in our alternate quantum realm universe, we get to factor this trinomial. I know my first term is going to be r, because r times r is r squared, and then I pull in my minus 1 and my positive 45. All right, that was our slip and our alternate realm P's and Q's. Now it's time to slide. Take the 5, I'm not going to slide the wrong number this time, and slide it underneath. If you can simplify the quotient, then you do it. If you can't, then you don't. Time to take it out of this alternate universe and bring it back into our universe. I cannot divide 1 by 5, so I'm going to split that or slide that 5 back out in front. So this becomes 5r minus 1. And I can do 45 divided by 5. That's 9. R plus 9. Is that what we got when we did it the other 2 ways? I do believe so. There's the last example using slip and slide. And that's it for today. In fact, that's going to be it until the end of spring break. So remember, this worksheet practice is due in Google Classroom you must submit an attachment of your worksheet completed. If you don't have a printer, which is no excuse because I don't have a printer either, guys, I'm grabbing a piece of paper, I'm folded it in half, I'm writing factor on the left, I'm writing multiply to check on the right. I'm taking a picture of this with my phone, which I know you all have because I remember seeing them back in the day when we were in the classroom. Take a picture of it with your phone, or if you have a scanner, you can scan it and upload it. Put it onto Google Classroom. This is due Friday, April 10th, like before Friday. Get it done now, okay? Tomorrow, there will be no new instruction. All we're going to do is I'm going to have an optional Zoom session at, I believe, 10:30 or 10. I have to remember what time it is. I'll post it on Google Classroom for you to ask me questions. And then that will be it until the end of spring break when we come back together and we continue distance learning until the end of the year. I miss all of your faces. I hope that you're having a good time out there, wherever you are and whatever you're doing. I hope you're doing okay. I am thinking about you and I am wishing you very well. So hopefully I will see some of you tomorrow live in Zoom. For the rest of you, I will talk to you after spring break. Bye, guys.